Hello everyone, I hope you all are fine. This is Arohi Saxena with a new video related to application of derivative, and the topic is increasing and decreasing functions. So let's start. Before starting the definition of increasing and decreasing function, I would like to discuss the meaning of increasing and decreasing functions with you. Okay, so for that I have considered one of the curve here, that is y equals to x square, and the graph of this curve is a parabolic function. Okay, so this is a parabola that I have drawn here. This is x and this is minus x, this is y and this is minus y. Here the value of x is greater than 0, and in this side the value of x is less than 0. Now first of all let's talk about the first quadrant. It means for the values of x that is greater than 0. If we increase the value of x, what is happening? The value of the y is also increasing. Okay, you can see it here also. If we put here x equals to 1, then y is 1. If we put x equals to 2, then y is 4. It means when we are increasing the value of the x from 1 to 2, what is happening? Your y is going from 1 to 4. It means it is increasing. Okay, so if on increasing x, y is also increasing in parallel, then we call it increasing. Okay, so for x greater than 0, it is increasing. So now let's talk about the second point, that what is happening here. This is minus x and this is 0. So the point goes like minus 1, minus 2, minus 3, minus 3, minus 1, minus 2, minus 3, minus 4, like this. Okay, so if we are going from left to right hand side, it means we are increasing the value of x. As you know that minus 10, then minus 9, so on to 0. It means we are increasing the value of x if we are going from left to right. So if we are increasing the value of x, what is happening with the graph? The value of the y is continuously decreasing. Okay, so it means x is increasing but y is decreasing. Both are having the opposite nature. So in this case, you can see it here also. We put x equals to minus 1, then y is 1. If we put x equals to minus 2, y is 4. So clearly x equals to minus 2 is smaller and x equals to minus 1 is bigger. Okay, so as we are increasing the value of x, increasing means we are going from minus 2 to minus 1. But what is happening from in y? Y is going from 4 to 1. It means x is increasing but y is decreasing. So this is the case of decreasing. So for x less than 0, this graph is decreasing. Okay, so if x is increasing and y is also increasing, then it is the case of increasing. If x is increasing but y is decreasing, then it is the case of decreasing. This is a very fundamental actually concept of increasing and decreasing function, and it is easy to understand the definition or the meaning of the increasing and decreasing function. Okay, so this is the clear concept of increasing and decreasing. Now one more case is there, that is the third case. For that we are going to consider one of the graph. This is the graph of the just a minute, you can see it clearly. This is the graph of a sine function. Okay, this value is pi by 2 and this value is 3 pi by 2. This is minus 1 and this is 1. Okay, and this is 0. So if you see this graph, okay, so if you are going to increase x from 0 to pi by 2, then what will happen? The graph is clearly increasing, your y is increasing. Okay, but if we talk about from pi by 2 to 3 pi by 2, then what is happening? That your y is decreasing. So here it was increasing and here it is decreasing. And if you talk about again the third section from 3 pi by 2 onward, then what will happen? Again the graph will increase. So in this particular graph, what is happening? It is increasing, then decreasing, and then again increasing. So in this case we conclude that this graph is neither increasing nor decreasing. Okay, this is the third case. But if we want to talk about that whether the graph is increasing and decreasing, suppose somebody asks you, then in that case your first question should be to that person that in which interval are you talking about. Okay, because this graph changes the behavior in different intervals. Like from 0 to pi by 2, if somebody asks you, you can say that the function is increasing. But if they ask you in from pi by 2 to 3 pi by 2, you will say the function is decreasing. Okay, so what is important here? The interval. So now let's talk about the next. What is that? Let I be an open interval. Now we are not talking about the whole domain, we are talking about just the interval. Okay, interval contained in the domain of real valued function f, then f is said to be, there are 4 cases. This is the first case. What is that? It is increasing on interval I if x1 less than x2 belongs to I. It means both the points we have considered from the interval only. So in this interval we have selected 2 points, x1 and x2, any 2 points. For that, it implies that our function value should be fx1 less than equal to fx2. It means if this is x1 and x2 and the value of fx1, that is y1, fx2, that is y2. So if x1 less than x2, then y1 should be less than equal to y2. Equal word is very important here, because it means it allows you, if x1 and x2 are 2 different points and x1 is less than x2, then you may get y1 and y2 such that y1 can also have the equivalent value to y2. y1 is either equivalent or less than y2. Okay, both the cases are there. So if this is the case, then we say the function is increasing. Okay, the graph also shows the same thing from here to here. If you consider this graph, then what is happening? That if this point is x1 and this point is x2, it means x is increasing. So x is increasing, but what is happening with the y? This is fx1 and this is fx2. Clearly you can see that fx1 is less than fx2. But if you talk about in this range, then what will happen? fx1 is equivalent to fx2 because the function is almost constant. Okay, so both the cases can be there. So if this is the case, then we say the function is increasing. Okay, now the second case. I told you the 4 cases are there. Now you talk about the second case. What is the second case? Is strictly increasing. What is strictly increasing? If x1 less than x2, again we are talking in the interval only, and we have taken these 2 points from the interval, then it implies that y1 is strictly less than y2. Just see this point. If this is x1 and this is x2, then fx1 cannot be equivalent. They are strictly less. It means x1 and x2 and this is y1 and y2. Then y1 and y2 cannot have the similar value. It means y1 is clearly less than y2. Okay, if x1 less than x2, then y1 is also less than y2. It cannot be equivalent. Then it is called strictly increasing condition. Okay, now the third case. What is the third case? Third case is about decreasing. Decreasing means if x1 less than x2, as you know, in decreasing, one is increasing, one is decreasing. So if x1 less than x2, it means fx1 can be greater than equal to fx2. It means y1 can be greater than equal to y2. Here you can consider the point. This is x1 and this is x2. So this point will be y1 and this point will be y2. x1, x is increasing, and here you can see that y is decreasing. Within this, again it can have the same value because the graph is almost constant. So this is the case of decreasing. Okay, now the last case of it, that is strictly decreasing. Strictly decreasing, x1 less than x2, then fx1 should be strictly greater than fx2. Okay, here if this is x1 and this is x2 and this is y1 and y2, here means y1 can never be equivalent to y2. y1 is strictly greater than y2. Okay, so these are the 4 cases. First is increasing, second is strictly increasing, third is decreasing, and fourth is strictly decreasing. After that, let's talk about the definition. I have taken only the definition of increasing. on the basis of that you can write any definition. Okay, a function f is said to be increasing at a point x dash if there exists an interval from x dash minus h to x dash plus h where h is a positive quantity that is greater than 0, such that both the point belongs to the interval. If x1 less than x2, then fx1 less than equal to fx2. Likewise, you can write any definition. Okay, you should know the concept. If you know the concept, you can write the definition very easily. Now, one of the example I have considered for you. What is that example? Show that the function given by fx equals to 3x plus 17 is strictly increasing on R. Here we are talking about R. So first of all, you consider 2 points in R. Okay. Now what is strictly increasing condition is if x1 less than x2, then fx1 strictly less than fx2. This implies this. Okay, so we are going to consider this condition. If x1 less than equal to x2, this is our condition. So multiply this x1 and x2 with a number that is 3, positive number. So it is not going to affect the relationship order. So 3x1 less than 3x2. Why we are multiplying with 3? Because we want to create this function. Okay. Now what is left? 17. So add 17 both the sides. Again it is not going to affect the function. So 3x1 plus 17. If you talk about fx1, then it will be 3x1 plus 17. So 3x1 plus 17 can also be written as fx1 and this can be written as fx2. So we took the condition x1 less than x2 and we got fx1 less than fx2. So this satisfies the condition of strictly increasing. So it means it is proved, it is shown that f is strictly increasing on R. Okay. So this is very easy. So in this video I have discussed only the definition as well as one of the example and the meaning of increasing and decreasing function. In the next video I will discuss the test with you. Okay. So thank you so much and stay safe.